In this short lecture, we'll talk about probability theory, and we'll see how the multiplication principle and what we know about combinations will introduce us to some basic but important probability theory. So we're going to start first with an example of spinning a spinner in a child's game. So the spinner has all the numbers from 1 to 10 on it, and each one is equally likely to be chosen. If you spin the spinner, each number is equally likely to be chosen, and if you spin the spinner once, what's the probability of getting a multiple of 3? Well, hopefully that's pretty easy. There are 10 things you can spin, and 3 of them, namely the numbers 3, 6, and 9, are multiples of 3. So the answer is 3 and 10. Now what if you spin it 8 times? If you spin it 8 times, what's the probability that exactly 2 out of the 8 spins will be a multiple of 3? So we're going to solve this by breaking it up into 2 separate questions. If you spin it 8 times, how many different results can there be? First. And this is like asking how many license plates there are with 8 places and a number between 1 and 10 in each place. So you're going to spin it 8 times. On the first one, you could get a number from 1 and 10. On the second spin, you could get a number between 1 and 10, etc. So by the multiplication principle, there are 10 to the 8th possible outcomes. 10 times 10 times 10, 8 times, 1 for each of the 8 spins. Now, out of those 10 to the 8th outcomes, how many have exactly 2 multiples of 3 in them? This one's a little harder, but we're going to use the multiplication principle and fill our license plate in 3 different steps. We're going to take the task of filling up our license plate into 3 steps. So in the first one, we're going to choose 2 of the 8 spaces to put a multiple of 3. So out of the 8, we're going to choose 2, and there are 8 combination 2 ways of doing this. This happens to be 28, but I don't care about the actual numbers. And then in each of those 2 spaces, we're going to put one of the multiples of 3, namely 3, 6, or 9. Since you have 3 choices for each space, and you have 2 spaces, there are 3 squared ways of doing this. And then in the other 6 spaces where you don't have multiples of 3, put in a number which is not a multiple of 3. And since there are 7 numbers which are not a multiple of 3 between 1 and 10, you have 7 choices for each of those 6 spaces, or 7 to the 6th ways of doing this. So 8 choose 2 ways of picking which places get multiples of 3, and 3 squared ways of filling those spaces, and 7 to the 6th ways of filling the other 6 spaces. So of the 10 to the 8th outcomes, how many have exactly 2 multiples of 3? Well, multiplication principle again. 8 choose 2, 8 combination 2, times 3 squared times 7 to the 6th. So out of all 10 to the 8th possibilities when you spin the spinner 8 times, this many of them, 8 choose 2, 3 squared, 7 to the 6th, have exactly 2 multiples of 3, and 6 numbers which aren't multiples of 3. So the probability is 8 choose 2, 3 squared times 7 to the 6th over 10 to the 8th, which we can also write as 8 choose 2 times 3 tenths squared times 7 tenths to the 6th. So the generalization of this turns out to be this. And hopefully, if that last example makes sense, this won't look too mysterious. Suppose you have a random event like spinning a spinner, and the probability of success, whatever success means, just the thing you're interested in, the success, which is p every time you repeat the event, so 3/10 chance of getting a multiple of 3, then the probability that you have k successes when you do it n times is n choose k, like that 8 choose 2, p to the k, that was the 3/10 squared, times 1 minus p to the n minus k. So 1 minus 3/10 is 7/10, and n, it was 6, k was 2, or n was 8, and k was 2, and 8 minus 2 is 6. So this is the generalization of that rule that we got by looking at the combinations and just using the multiplication principle. And here's an example. Maybe this will make it more concrete. If 13% of all people are left-handed, and you choose 8 people at random, what is the probability that exactly 3 of them are left-handed? So remember the formula we just had on the screen. N choose k, p to the k, 1 minus p to the n minus k, and that tells us that the answer to our question is 8 choose 3. 8 people, and you want 3 of them to be left-handed. 0.13 cubed, so there's a 13% chance for each person to be left-handed, and you want 3 of them. And times 0.87 to the 5th. There's an 87% chance that someone's not left-handed, and you want 5 of those. And when you multiply it all out, you happen to get 0.06. So hopefully this quickie introduction will give you the background you need to do the homework for next week.